While talking of Michelson-Morley experiment, we say that fringes are formed in the view of this telescope. Now, I have gotten this question from several students that if the two paths on the two sides are same and the phase difference is 0, how come fringes are forming? Why there should be a bright and dark if the phase difference is 0, should only be bright? So, let me answer this question, and before that let me once again tell what is that Michelson-Morley experiment itself. So, essentially what you have is a light coming and then light falling on a plate from where part of it is reflected and then part of it is refracted. It is very thin, so there is too much of exaggeration that I am showing this shift. Then you have a mirror here, then you have a mirror here, and this mirror reflects the light which comes here, and then part of it is reflected and part of it is going into it. Similarly, this mirror reflects, call it M2, M1, this is M2. This mirror reflects and that comes here, part of it is reflected and part of it is transmitted. And it is, these are the rays which we are talking, one coming from this side, one coming from this side, it is going, coming and then reflecting from here. A part is also refracted, but anyway that goes west, and then the other one is this one which is going and then reflecting and then coming, and then part of it is reflected, but we are concerned with this one. So, these two beams which have come through two different paths, they interfere. In actual design you also have a compensating plate because one beam is going through this thickness, the other is not, but those things are not much important for this discussion. Now, if the total path travelled in this direction, the total path travelled in this direction, if they happen to be exactly same, if they happen to be exactly same, yes, the phase difference is 0 and you should get a bright there. But then what I have shown here is just one ray, one path, whereas the telescope has its own field of view, its own field of view. So, you not only see what is here, you also see what is here or what is here or what is here or what is here. So, the light which is coming from here is not one single ray, of course it is a beam, and that beam is going and that whole beam is going here reflecting. Some parts of that beam will have a path so that it will reach here, some path will be there so that it reaches here. So, at this place beam coming from first path, beam coming from second path will have a different phase relation, whereas in this place they will have a different phase relation, this place they will have a different phase relation, and so on. Therefore, when you see this big view, that means you are seeing an aperture, not a single ray, but an aperture, a beam, and different places will receive beams which are from different portions and they have covered different paths, geometrical paths will be different. So, at some places you will have bright fringes where the path differences are integral multiple of lambda, or phase difference is integral multiple of 2 pi, and then other places you will have dark where the phase difference is pi, 3 pi, odd multiples of pi. So, that is how the fringes are